Erode Senbuntar Namma College Robotics Automation Ninga Sol.
Hello everyone, myself Karthik M, working as an assistant professor in the Department of Robotics and Automation. In this video, we are going to see a topic from the subject of Fluid Power Systems Laboratory. Have you ever wondered how heavy machines like excavators, cranes, and factory automation systems operate? The answer is fluid power, specifically hydraulics and pneumatics. So, in this video, we will explore the basics of these powerful technologies, their working principles, and their real world applications. The words hydraulics and pneumatics have Greek origins. Hydro, it means water, and aulos means pipe or tube. It originally referred to the water driven systems such as ancient hydraulics, a type of water powered organ. And the word pneumatics, it is derived from pneumo, which means air or breath. It signifies systems that use compressed air or gases for the movement and power transmission. Hydraulics uses liquids under pressure to generate force and motion. It is based on Pascal's law, which states that pressure applied to a confined fluid is transmitted equally in all directions. For example, imagine pressing a syringe filled with water. The liquid transfers the force evenly, just like how hydraulic systems power heavy machinery. The basic components of hydraulic systems are a pump to pressurize the fluid, valves to control the flow, cylinders to generate motion. The application of hydraulics is it is used in excavators, aircraft landing gears, hydraulic presses, and vehicle braking systems. Next, we have pneumatics, which uses compressed air or gases instead of liquids. Pneumatics follows Boyle's law, which states that increasing the pressure decreases the volume of a gas. A pneumatic system includes an air compressor to generate compressed air, control valves to regulate airflow, actuators to create movement. So the applications of pneumatics are in air brakes. So the applications of pneumatics you will find in air brakes in trucks, spray painting systems, robotic automation, and medical devices like ventilators. So from this we can get to know that hydraulics is best for high force applications while pneumatics is preferred for faster, lighter operations.
We are going to see about the hydraulic double acting cylinder. We are going to simulate them by using a simulation software. It is called as a AutomSim software. So we are going to simulate the hydraulic double acting cylinder in the sequence of A plus, B plus, and then A minus, B minus. Using electrical controls. So we are going to use the solenoid control switch cylinder. So solenoid means it is an electromechanical device through which we can control the mechanical instruments by using the electrical switches. So that is the purpose of solenoid control. So we are using this hydraulic cylinders in industrial point of view in cranes and hydraulic jacks. Those things are applications of this hydraulic double acting cylinders. So now we are going to see in the software how to insert the components and then simulate the. So this is the hydraulic double acting cylinder circuit diagram. First one is the hydraulic reservoir. Reservoir we are going to store the oil. So from oil we are going to pump it into the direction control valve and then into the cylinders, double acting cylinder. So by using electrical switches we are using 24 volt switch, your power supply, to control the two double acting cylinders. So this is the working fourth cylinder. So we are going to use Autumn Sim software. This one is primarily used for simulating the hydraulic circuits and pneumatic circuits, and also by using the electrical controls. So initially we have to see the circuit diagram. So this is the circuit diagram we are going to draw. So in order to draw the components, we can add the objects which are all already available in this library. So initially we have to open and then see the hydraulic. So in the hydraulic we can see actuators, and in actuators it is called as cylinders, and we are going to insert the double acting cylinder. So this is the double acting cylinder we are going to use. So in circuit diagram we can see that there are two types of hydraulic cylinders. First one and second one, we are going to name it as cylinder A, and then next one is cylinder B. So from this only we are going to see the A plus B plus. So A plus means extension of the cylinder A. B plus means extension of the cylinder B. B minus means retraction of the cylinder B, and A minus means retraction of the cylinder. Okay. So previously we have seen the simulation of hydraulic double acting cylinder. In software we have seen. Now we are going to use the practical original kit. So this one is the oil hydraulics trainer kit, in which we are going to use the oil for the application oriented purpose for extension and retraction of the double acting cylinder. Initially we need to know what are all the components used in this experiment. Basically we are having storage tank. So we are storing the oil in the oil tank. It is also called as reservoir. Then we are going to pump to the circuit. So initially we are having pressure gauge. We are going to regulate the pressure, and on off button. That one is called as a starter, and we are going to use the solenoid switch. Already we have seen solenoid switch means it is the electromechanical device. We are going to control the mechanical devices by using electrical controls. So that is the purpose. Next we are adding the pressure manifold, and then we are going to direct it to the direction control valve. So from direction control valve we are going to feed it into the double acting cylinder. So from double acting cylinder we are going to see the extension and retraction of the actuators. So now we are going to work. So now I am going to start the motor. So this one is the starter, this one is off button, and this one is the on button. So now I am going to turn on. So here we can see the pressure level in bars. Next one we are having the on off switch. So I am going to turn it on. First we are going to see A plus. Already we have seen A cylinder, B cylinder like that. Here we are having one cylinder. We are going to see the extension. So I am going to turn it on. So we can see the motion of the cylinder actuator. This one is the piston which is moving outer direction. So after reaching its full extension level, we can stop and we can go for the retraction. So we have to turn on the retraction level, switching solenoid switch, so we can see the retraction. So finally reaching its end position. So I can turn it on. So after simulating, we can turn off the switch. And finally we have to turn off the motor. So this is the working of the hydraulic cylinder. Tell me, what is this component?
This is DCV, sir, full form direction control valve.
So where it is used?
Hydraulic pneumatic types.
Systems. Okay. What type of DCV is used in hydraulic and pneumatic systems?
5x2 or 4x2 direction control valve. Double acting cylinder is what?
Very. Hari Prasad, tell me, what is the primary difference between hydraulic and pneumatic systems?
The hydraulic systems using incompressible fluid, by pneumatic system using compressible fluid, sir.
Tell me some examples.
Hydraulic system is oil, pneumatic system air. Good.
Maudikanan, so tell me what is a double acting cylinder?
So double acting cylinder is a pneumatic and hydraulic actuator. Sir. It will receive pressure on both sides of our pistons. So it will extend and return. So while giving pressure, it will extend and also it will get returns.
Very good. What is the function of direction control valve?
So the direction control valve to flow the fluid or add to the movement of the actuator.
Very good. So Sugandan, tell me what is this component?
So FRM,
So what is the full form of FRM?
filter, regulator, lubricant.
So what is meant by FRM?
So use it to filter the air, regulating, lubricate the air, so smooth operating.
In which system? Hydraulic or pneumatic system it is used?
So pneumatic system.
Okay. Very good.
Like
Monica Stuti, tell me what is this component?
So it is a pressure relief valve, sir. It is used in hydraulics. It prevents excessive pressure buildup, but it diverts the excess fluid into the pressure.
Okay. Very good.